Here we're going to go through a few real-world situations and practice writing equations. So we're going to use the steps on the left. If you could please pause and read through this problem. So when they're asked to define the variables, I always look at the question because variables are unknown numbers. So what don't we know? We don't know the dimensions of the garden. And this is a rectangular garden, so that's going to be our length and width. So I'm just going to call that L and W. Now let's start to set up the structure of our equation, and then we can fill in the numbers. So this is telling us about the perimeter. So remember, perimeter is just kind of going around. You're adding your length plus your width plus your length plus your width. Or you can simplify that in thinking of you have two lengths. So we're going to take 2 times the length and 2 widths. We're going to add 2 times the width, and that's going to give us the perimeter. So if we just put in L and W, we're not going to be able to solve this because we just have information to make one equation. So when you just have one equation, you can only have one variable if you want to solve for that variable. So let's look at some of the other information they're giving us about the length and width and see if we can represent that with just one variable, one letter. So it tells us the length is twice the width. So think about what that means. The length is twice as big as the width. So if this is W, then the length is 2 times W. So I'm going to modify my let statement over here, and I'm going to call the length 2 times W. Now let's start substituting in what we know into this structure. So this is saying 2 times the length. And remember, the length is 2W plus 2 times the width. The width is W equals the perimeter. If we look back up to the problem, we see the perimeter is 60. So that is our equation. Now I'm going to pause it and solve it real quick, and we can talk about what the answer is. So here we found out that W equals 10 by combining our like terms and then dividing. So I can't just say W equals 10. With these sort of problems, you could solve your equation and get it right, but you need to go back to the problem and figure out what question they're asking and how you should define your answer. So remember, they're asking what are the dimensions of the garden. They want to know what the length is and what the width is. So we need to go back to our let statement where we defined our variable. This is why it is important to always write out what those variables are. So the length, remember, is 2 times W. So if W is 10, the length would be 20. And the width is W, so it is 10. And then look to see if you need to label it with any sort of units. If we go back up to the perimeter, we see it is 60 feet. So the length is 20 feet, the width is 10 feet. Let's try another one. So again, why don't you pause it and read through this situation. So our first step is to define the variable. Again, I always look to the question to see what they're asking. That's our unknown. And the unknown is how many trees did the farm have initially to start with. So I'm going to call that I. Now let's start to think about what's going on here. Let's not jump into just the numbers. Get a good understanding of the situation. So I made this marvelous drawing here of an orchard of the McDonald farm, and these are their trees, and these are orange trees. Okay, so they're each producing oranges, and it says that they each produce 210 oranges, each of these trees, and they're telling us the total harvest. So if we think about what's going on, we have the trees. Each of the trees produces So this is like the number of trees. Each of the trees produces oranges. So I'm just going to say oranges produced. And then we multiply the number of trees times the number of oranges each tree produced. That's going to give us our total harvest. Now, unfortunately, it says that you had this amount initially, like this is your starting amount of trees, but there were some insects. And so you had to cut down 5 of these trees. So when we're plugging in our numbers into this kind of structure of our equation, you had the initial number of trees here, which is I, but you had to cut down 5 of them. So the number of trees that you have is the initial amount minus 5. Now let's see, how many oranges did each of those trees that are left produce? 210. And then the total is 41,790. So this is the equation that I'm going to go through and solve. Now this might look kind of strange because there's this in parentheses times this. I'm just going to switch the order. The commutative property allows me, like if I had 3 times m, I can change that to m times 3. You can always switch the order. So I'm going to change this to 210 times I minus 5. So that's in more of like the order I'm used to before I start distributing to solve. So now I can distribute that 210 and solve for I. So when I distribute and move things around, I see that I is 210. So if I look back to the question, how many trees did the farm have initially? Remember, I is the number of initial trees. So the answer would be 210 trees. Let's try one more here. So pause and read through this question. So when I define my variable, again, I'm looking at the actual question, and this one actually tells me what letter to use, which is fine. It says, what is the original price per pound? And I'm going to call it P. So I'm just going to write that down. So this is talking about apples. So you buy the apples by the pound. So if I think about this, I'm going to have the number of apples, and how they figure out what to charge me, they're going to take the number of pounds of apples and they're going to charge me per pound. So I'm going to multiply that by the price. And when you take the pounds of apples times the price, that will give me the total bill, how much they're going to charge me. So let's think about what's happening. Here it says that the price went up 85 cents. So if the price, for example, was $1 originally, now they're going to charge me $1.85. Right? So kind of think of an example and think of what happened. If this was my original price, they're taking that original price, which is P, and they're adding 85 cents to that. So the price that they're charging me for the apples is the original price, P, plus 85 cents. That is my new price. Now I am going to be buying 4 pounds of apples, and the total is $7.88. So this would be my equation to solve. So when I distribute that 4 and then move things around to get P by itself, I see that P is 1.12. So if I go back to the question, it says, what was the original price per pound, which is P? So it would be $1.12 per pound.